Welcome to our next video lesson, which is Science 6 Quarter 1 Week 1. But before that, don't forget to hit the like button and subscribe. Department of Education, National Capital Region, Schools Division of Parañaque City, Science 6 Quarter 1 Week 1 Self-Learning Module. Learning competency. Describe the appearance and uses of uniform and non-uniform mixtures. Objectives. At the end of this activity, learners should be able to describe the appearance and uses of solutions such as solid and solid, solid and liquid liquid. So what is a solution? A solution is a homogeneous mixture. Homogeneous mixture has the same properties throughout the sample. It means that the substances mixed thoroughly after stirring appeared as one substance. You can no longer distinguish one component from the other. Let's have a recall. Directions. Study the two figures below and answer the questions that follow. Write your answer on the space provided. We have here two figures. On the figure 1, we have sugar and water. And figure 2, we have sago and gulaman. In our figure 1, we're in sugar in water. So the circles represents the sugar. So here is the sugar in water. And in our figure 2, we have sago and gulaman. And our sago and gulaman components are, so the oval represents sago, rectangles represent gulaman, triangles we have the syrup, and circle as sugar. So we have here three questions. Question number 1. Which has a uniform appearance? When we say uniform appearance, it is a mixture that is a homogeneous mixture wherein all of the substance appear as one. And then we can no longer distinguish the two substances dissolved in that solution. So which do you think is the figure that has a uniform appearance? Is it the sugar in water or the figure that represents the sago and gulaman? How about our question number 2, which has a non-uniform appearance? Non-uniform appearance wherein you can still see the properties of each component of the solution. Just like here, we have here, it represents the sago, and the triangle is the syrup, and the rectangle is gulaman. So, what do you think is the answer for number 2? How about number 3? Can you now describe the uniform appearance and the non-uniform appearance? You can create your own description of what is a uniform mixture and what is a non-uniform mixtures based on our two figures represented here above. Let's have this exercise for our Let's Recall. Directions. Tell whether the following mixtures are non-uniform or uniform. Write your answer on the space provided. So we have here picture number 1. Now the picture number 1 says here it is air composed of our oxygen, nitrogen, and carbon dioxide. Is it uniform or non-uniform? Can you distinguish those air or different gases at the atmosphere? If you can distinguish them, is it a uniform or uniform appearance? How about for our second picture? a picture of a soda. Is it a non-uniform or uniform? Okay, so let's proceed with the next picture. Water. Is it uniform or non-uniform? It is, the component of water is oxygen and water, of course. So next, salt and pepper. Is it a non-uniform or uniform mixture? So as you can see, there are some of pieces of particles that you can see. So is it uniform or non-uniform? Okay. So if you have already written your answer, let's proceed with the next picture or next mixture. It is a mixture of sugar and sand. So this is a picture that represents the mixture of sugar and sand. Is it uniform or non-uniform mixture? So I hope that you already answered all these mixtures and then you got all the answers correct. Before we proceed with our lesson proper, let us first understand the states of matter. We have first the solid. They are the relatively rigid, definite volume and shape. In a solid, the atoms and molecules are closed or attached to each other. How about the liquid? Liquid has definite volume but able to change shape by flowing. In a liquid, the atoms and molecules are loosely bonded. And we have the gas. Gas has no definite volume or shape. So we are going to encounter these states of matter in our discussion. Oh, don't forget what are the meaning of solid, what is a liquid, and what is gas. There are 5 types of solutions. All these types are homogeneous. When we say homogeneous mixture, these are the mixture that have a uniform appearance. The first is the first type is solid in liquid. Solid substance is dissolved in a liquid substance. Examples are sugar in water, salt dissolved in water, juice powder in water, or coffee in water. So the solid here are the sugar, the salt, the juice powder, and the coffee powder. And the liquid is, of course, we have here all are water. Well, that is solid dissolved in liquid or solid in liquid. They are being mixed together. Next, we have liquid in liquid. So liquid substance can also be dissolved in another liquid. And these two substances can be mixed thoroughly. Examples of these are alcohol and water, wine and soda water, concentrated fruit juice in water. So all of these two substances are liquid. So alcohol is liquid, water is liquid, wine and soda water is of course liquid, and fruit juice in water are liquid. So we have here liquid dissolved in another liquid. So next solution that we have here is gas in liquid. Yes, we have here gas in liquid. Certain liquids contain gaseous substances. Soft drinks appear as liquid, but they contain carbon dioxide gas. This can be observed when a bottle of soft drink is shaken or opened. Bubbles appear and gas is released. Oxygen is also present in water. Plants use them during the food making process. So don't forget that there are some of the liquid that we have contains gas, just like our soft drinks, which contain carbon dioxide gas, and our water that contains oxygen. So that is a solution between gas and liquid. Our next solution is gas in gas. Air is a very good example of gas in a gas solution. It is a mixture of several gases such as oxygen 20.95%, nitrogen 78.09%, carbon dioxide 0.03%, argon 0.93%, and several trace gases such as water vapor, methane, and ammonia. So our atmosphere is composed of different gases such as oxygen, nitrogen, carbon dioxide, argon, and water vapors. Next, and the last, solid in solid. Steel, basically a solution of carbon atoms in a crystalline matrix of iron atoms. Alloys like bronze and many others, polymers containing plasticizers. So our steel is basically a solution of a different ions or atoms. So these are solution or mixture that create one appearance only. So making them a homogeneous mixture. So these are the five types of our solution. Let us now apply what we have learned in our discussion. Direction. Complete the table by filling in the components and appearance of the given types of solution. So we have here in the first column the types of solution. On our second column, we have here the components and the appearance. Is it uniform or non-uniform? So you're going to think a solution that is a liquid dissolved in liquid. So that is the first. So what is the components and then what is the appearance? The next type of solution is solid in liquid. The next, gas in liquid. And then solid in solid. And the last one is gas in gas. So are you ready now? Okay, so that's very good. Okay, so you are going to fill in the components and then the appearance. Don't forget that we have two appearance. We have the uniform and non-uniform appearance. I know that you have already written your answers by filling in the components and appearance of the given types of solution, but let me present to you some of the examples that I have already prepared for you. So we have here the first type of solution, liquid in liquid. The two liquids are alcohol and water, and their appearance is uniform. Very good. Next, solid in liquid. What is the solid here? This one, the juice powder, and then the liquid is water, and their appearance is uniform. The next type of solution, gas in liquid. Our gas here is carbon dioxide, and our liquid is soft drinks. And the appearance, of course, is uniform. Next type, solid in solid. What are our components here? Iodized salt and rock salt. When we're going to mix iodized salt and then rock salt, of course, the appearance would be non-uniform because we can still distinguish iodized salt and rock salt from our mixture. Next, the last one, gas in gas. Water, vapor, and methane. So, we cannot see the appearance because, or we cannot distinguish the appearance of water vapor from methane because it is in the form of gas. So, our appearance would be uniform. So, how about you? Are your answers correct? Did you have your own examples or did you answer your own activity in our Let's Apply correctly? If you answered it correctly, then that's great job. Let's analyze the table presented here. So we have here in the first column the example of solution, which is salt solution. What are the components of the salt solution? We have salt and water. What is the solute? The solute here is our salt. And what is a solvent? The solvent is the water. So how are we going to define solution, solute, and solvent? So we have here an explanation of what is a solution. A solution is formed when one substance is dissolved in another substance. When a substance is dissolved, it breaks down into molecules. So that is a solution when one substance already is being dissolved in another substance. So we are now going to differentiate what is a solute and what is a solvent. When we say solute, it is a substance that dissolves in another substance, while a solvent is a substance that dissolves a solute. So here in our table, here in our solution, which is a salt solution, the one that is being dissolved here is the salt. That's why it is our solute. And the one that dissolves our salt is the water. That is why when we are asked what is the solvent, we answered water because it is the one responsible in dissolving our salt. Okay, so can you now differentiate between a solute and a solvent? If the answer is yes, then I think that you are now ready to our next activity. We are now on our next activity, which is the Let's Evaluate. We are going to complete the table below by giving the solute and the solvent of the given types and examples of solution. So we have here the types of solution wherein it is in our first column and the example is or the examples are here on the second column, and then we're going to identify what is the solute and the solvent. So on our first type of solution, we have liquid dissolved in gas. So what are the components of the vinegar that are solute and solvent? So you're just going to give me one solute and one solvent. How about in gas dissolved in liquid? What are the components of wine which represent gas, and then liquid? And of course, we have also here the soft drink. What is the gas present in our soft drink and liquid? Then the last, we have solid dissolved in liquid. What do you think are the components of dental amalgam? And then what is the solute and the solvent there? And the last one, we have sugar solution. So if we have sugar solution, what is the solute and what is the solution? Or the solvent, I mean. I have here prepared for you an example. So these are just some of the examples. So you are going to get an idea on how you are going to answer your own activity. So I have here liquid dissolved in liquid, vinegar. Then the solute is the sugarcane vinegar, which is also a liquid because we are going to have a type of solution that is liquid dissolved in liquid. So we should have liquid and liquid. Sugarcane vinegar is a liquid, and then here in our solvent is water, which is also a liquid. And then gas dissolved in liquid. We have here to discover the components of wine, and then the gas in our wine is nitrogen, and then the liquid is water. How about for soft drinks or soft drink? We have here carbon dioxide, which is a state of matter of carbon dioxide is gas, and then the solvent that we have is water. So carbon dioxide and water are present in our soft drink. Then solid dissolve in liquid. So in our dental amalgam, the solid there is silver, and then the liquid is mercury, wherein the mercury is under our solvent. So we have solid dissolved in liquid. Then the last one, we have sugar solution. Our solid and solute is sugar, of course, and then our solvent wherein the sugar will be dissolved is the water, and that is liquid. So don't forget that we have here types of solution, and then you are going to base the components of the solute and solvent here in our examples presented on column 2. Okay, so please answer or fill in the needed information here at the column 3 and column 4 for our Let's Evaluate. So we are now here on our Let's Create part. So for Let's Create now, letter A, mix dishwashing liquid, oil, and water in a bottle with a lid. Shake them and let them stand for a while. Observe what kind of mixture is formed. Why are the different substances immiscible? Draw the mixture you formed. Label the components of the mixtures. But what do you mean by immiscible? When we say immiscible, it is not forming a homogeneous mixture when added together. Why do you think that when we mix dishwashing liquid, oil, and water in a bottle, do not create a mixture that is homogeneous or have the same appearance? Why do you think? And then, of course, you're going to draw the mixture you formed and label the components of the mixtures. And then letter B, you are going to prepare the materials here, powdered juice, warm or cold water, spoon as a stirrer, and then of course a glass. You need these materials because you're going to prepare a process flow chart in the preparation of a fruit flavored drinks at home. So you're going to make a process flow chart on how you're going to prepare a flavored drinks at home. So let's get ready with the materials that you're going to need and then submit your product. Thank you for listening and learning with Teacher Room. Don't forget to like and subscribe so you will be updated on our next video lessons. Credits: this presentation template was created by SlidesGo, including icons by Flaticon and infographics and images by Freepik.